Having to wait an age for a film or television programs to download is one of the minor peeves of modern life. But snail's pace internet could become a thing of the past, as British researchers have found a way to make sending information 50,000 times faster. The scientists used fiber optic cables that sent information at the rate of 1.125 terabits per second, which could be used to download a HD box set in less than a second. That's 50,000 times faster than the current superfast broadband rate of 24 megabits per second, the researchers say. The researchers' record is 12.5% higher than the previous record from last year set by Mitsubishi and Alcatel-Lucent, who achieved 1 terabit per second. The record applies to a single receiver. The researchers suggest combining many receivers could result in a transmission of 1 petabit per second. 1 petabit is 1000 terabits. Lead researcher Dr. Robert Marr of UCL's Electronic and Electrical Engineering Department said, "To give an example, the data rate we have achieved would allow the entire HD high-definition Game of Thrones series to be downloaded within 1 second. The researchers used fiber optic cables that transmit information through pulses of light sent by a laser down a glass fiber. Their breakthrough was to use techniques used to compress information in Wi-Fi signals, which are sent by radio waves, on optical signals. To break the speed limit on the information superhighway, the researchers used methods of encoding information for optical signals down fiber optic that are currently only used to send wireless signals." Dr. Marr said, "This ultimately resulted in us achieving the greatest information rate ever recorded using a single receiver." Professor Polina Bavel said, "This result is a milestone, as it shows that terabit per second optical communication systems are possible in the quest to reach ever higher transmission capacities in optical fibers that carry the vast majority of all data generated or received." A high-capacity digital communications infrastructure underpins the Internet and is essential to all aspects of the digital economy and everyday lives. The researchers will now test the system and attempt to get the high-speed data rates over long distances rather than just within a laboratory. Over long distances, optical signals can become distorted as they travel through thousands of miles of optical fibers.